The ATOS core system consists of three main elements: the left camera, the right camera, and the projector in the middle. The definition of left and right results from the sensor view. The left camera and the right camera are calibrated relatively to each other, which means the angle in between the cameras is known. Therefore, you may call them stereo cameras. The angle in between the cameras results in a distance from the sensor to a point at which the camera rays meet. This distance is called measuring distance. At the measuring distance, the stereo cameras span a three-dimensional area. This area is called measuring volume, in which 3D points can be computed. The size of the measuring volume depends on the sensor type. The sensor projects fringes onto the measuring object. This measuring process is captured by two cameras and will result in 3D coordinates of the camera image pixels. The resolution of the stereo cameras depends on the sensor type, but can result into up to 5 million points per scan. You will get the 3D data information from those areas which were visible for the sensor. Please note that data are captured only for areas which were visible for both cameras simultaneously and are within the measuring volume. In order to capture the object entirely, more scans from different positions of the object are necessary. However, if you take another measurement, there is no information about the correct orientation of this measurement. Reference points are used to automatically combine the different scans together in one common coordinate system. As soon as a measurement is taken, the ATOS system determines the position of the reference points in 3D space and also the distances between the reference points as a reference point pattern. From this point on, the points are known to the system and thus get a distinct number. The system recognizes the reference point pattern and can therefore triangulate its own position in 3D space relatively to the position of the object. At least 3 reference points must be visible for both cameras of the sensor in order to determine the sensor position. You may now move the object or the sensor, whatever is more convenient for you. The system always gets its orientation from those points and does not rely on fixed object or sensor position in 3D space. So what happens during a scan is that the system determines its position relatively to the object. Then the fringes are being projected to calculate the coordinates of the camera image pixels in 3D space. As the software knows where the sensor has taken the measurement, it knows where to put the scan data and it does this automatically for you. Repeat the scanning process until the object has been captured entirely. Please note that you must not move the object relatively to the reference points after a scan has been taken.